Hi everyone, welcome to the MathSpellBook live stream. I'm your host Peter, and basically we're going to continue on with math proofs today. Hello, Lally Sally? I think, I don't know if I'm pronouncing that correctly. Or is it, Lally Sally? I apologize if I mispronounce your name, because the way I read it, it looks like it says like, because like I don't know if like the L-I-E is supposed to read as lie, or is it supposed to read as Lee? If you're still in the chat, like please correct me how to pronounce your name correctly so I can address you correctly if I'm mispronouncing it. And if you want me to call you by a short name like Lali or Lalai, let me know. But what's the best part of your day so far? Anyway, let's get back to what we were doing yesterday. So I did try to do a couple of these proofs like last night. Of course, I had to use ChatGPT to basically like help me out with that, so that I can better understand. And I think for the sake, the thing is that I don't know if I should turn off the Twitch chat. Maybe I should just like not let the chat be visible, because it kind of blocks everything, and the important stuff is usually on the screen. So let me just find where the Twitch chat is. There we go. I can still see you guys, it's just that I don't have it on screen. So unfortunately you guys can't see what's being typed in chat. So I will probably put it up if you guys want to read what, if there's like important facts that you guys type up, I will show the chat. So next part is, so let's get started. This was like the physics problem that I was kind of showing. Oh, Lala, okay. So is it Lala Sala? Is that how you pronounce it? That's interesting. Is it like what pronunciation is that from? Is that like from a different language? I'm wondering. Because usually when I see like L-I-E, I usually assume it's like a Lee sound. But that's interesting. That's very interesting. Okay, so I think we have it. Okay, let's get to it, shall we? And I also have ChatGPT like up here just in case, so we could probably hurry things along. It's like Lala, exactly. It's a Lee sound. So should I just call you like Lala? if it's convenient for you. So I think we got number 2 here, and number 2 says if y1 is a subset of y2, subset of y2. Yeah, it really doesn't matter. Okay. So, do you mind if I ask where you're from, Lala? And like, what got you into mathematics or physics or both? Okay, so actually I should bring this up a little bit more up here. Oh no, bar kind of blocks it. Okay. All right. So proof. Okay. So we're going to have to do this. Oops. Have to write senses. Let x be an element of y by the... Even though I did it last night, or like, you know, I tried to do it and ChatGPT helped me out, I still don't remember exactly how the proof is written, so I'm trying to recall a little bit more on what I learned last night. So this is basically just recall of pre-image. Oops. Pre-image. Just drag this over here. F of x is equal to f of y. Okay. So there exists a y which is an element of Li1 such that f of x is equal to y. Since we know that y1 is a subset of y2, y is an element of y2. Thus, Actually, maybe I should write the basic function first. X is an element of y2 and by definition of pre-image, by definition of pre-image, X is an element of F let's drag this down. Therefore, F of Y is a subset of F of Y2. Okay. I think that's how it works. I mean, I think that's how we define things in this proof. Because basically we have all the pieces here. So I guess I remember more than I thought. By definition of the pre-image, I think that should be fine. If anyone in chat basically sees any flaws with the way I wrote this proof, let me know. Okay, so I think we can start on number 3. Well, actually, part 3 of 1. And I think we have to go into, because the problem is supposed to look like this. Because Sascha told me he made a mistake in the writing of it when he wrote the sheet. So it's supposed to be y1. Wait. Okay, I thought I was getting my symbols mixed up. Because I was like, oh wait. So it's that. And F of X, Y1, right? Hey, Sascha. Actually, Sascha, since you're here, I was actually doing some of the proofs of part 1 of exercise 1 last night. I think I did up to like these. I mainly used ChatGPT to help me like understand how to write the proofs. So I tried to do this one to basically see how much I remember from what I learned from ChatGPT. So if you have any criticisms about this proof, let me know. I want to make sure that I didn't miss anything. I'll let you have a quick look at it. Hopefully things are going well at your end, my friend. Yeah, it looks fine? Okay. Yeah, I think with ChatGPT it broke it down a lot much easier for me. So now I gotta see what I can remember from this one. So I did learn a lot from ChatGPT, and I have it like literally in my browser just in case if I get stuck. Proof. Okay. So y is subset. So I gotta remember. This all has to do with pre-image definition, so we're gonna use the pre-image definition again. I think like all of these proofs involve pre-image. So y1 is a subset of. Okay. So I think we have to define basically the function here. So we have x is an element of. Oops, no. We have to write sentences. Don't start writing Don't start writing mathematical stuff yet. Let x be an element of y1 by definition of a pre-image f of x is an element of y1. Okay, so now we gotta actually be clever here, because now we're gonna have to so there exists, well, actually I think like what I read in a math book is that you have to write like there exists like in words. You can't write symbols at the beginning of a sentence. I was explaining to someone how the tensor product is used to define the pre-image in algebraic geometry. Oh, that sounds interesting. There exists y, which is an element of y1, such that f of x is equal to y. Or maybe y1. No. Should it be all y? This is why I'm doing this, because even though I saw it last night, I don't want to look at what I wrote in my notebook from what I learned. So we have there exists y, which is an element of y1 such that f of x, no, because then basically this is why it's practicing. So basically it's like, I feel like in this case, because we already defined x as an element of this, and there exists maybe we should take this part out, because I feel like I'm not really sure about this next section here. So we got the definition of a pre-image, so that's something we definitely need. Now the question is, how do we actually do this? Maybe we have to show that the pre-image of this part, so we have to actually show, the pre-image of this part, but now we actually have to show the image of this part. Maybe that might be what we need to do. Oops, didn't mean to erase that much. Well, at least we got like one proof done. That is an achievement. At least I remember that, like how to actually do that one. So this one, we're actually going to have to like work our muscles to actually recall stuff. Now, of course, I don't remember the whole proof, but at the same time, I think that's better because it allows me to exercise the muscles. Okay, by definition of a pre-image. So now what we have to do is get the meaning of this image. Since all of because I don't want to assume things either, but at the same time it's like, should we put there exists or for all y that is in y1? It's like one of those questions where you're like, is it basically only one, well not one, but like a particular y that gives you the function, or is it like all y within y1? But then again, when it's a function that's basically, and you have a set of something, it would probably require all of it. I know I'm like just spitting out like ideas, like basically, because I think when we think about a pre-image for the function here, we want it to account for all cases. And it's a function, so basically anything you put into it has to give, like, you know, something from the set that it's talking about. Let's see. So we have this. By definition of a pre-image. X is and forgot the period there. And since all of y is an element of y1, x is an element of y1. Okay, so we proved that basically x is, I mean, that's obvious, but at the same time it's like, now it's the question of, now what? It's like, what are you gonna do with that information? Now what? So, if that is the case, Maybe this part we have to answer this big thing. Not this. Like, maybe that's the thing we gotta do. Because we already answered this. Maybe we have to let x be defined by the whole thing. Maybe that might actually like work. I think that's what we needed to do. I think I was just trying to break it into pieces because that's what usually I do whenever I try to solve computational problems. Like so. Okay, so let x be an element of that. By definition of a pre-image by a pre-image, that would mean that write a pre-image like this, that would mean that basically y is equal to this. However, in our case, we have a little bit more involved here. So, if this gets us x, so I gotta think here. So if this turns into this, right? Then okay, so the thing inside it goes outside. So if we think about it, then this would go out here is an element of x, fx. I think that's how it would work. So after this part, there exists just forgot to put the little one there. feel like I can get this. It's just that parts of my memory are like kind of like, I'm not trying to remember, I'm trying not to like remember too much, because the thing of it is that like I also want to follow the logic here. It's like by definition a pre-image F1 verse. So whenever we write this, I mean, that seems like it's obvious, but I just felt like I should restate it, at least. Because we have a pre-image in a pre-image. I mean, not a pre-image, but basically an inverse within a function, and then basically we have to like show like the pre-image of it. Making it too complicated, or I'm overcomplicating it in my head. By definition of the pre-image, maybe we shouldn't write this part yet. Oops. I think like by definition, it's a pre-image X. Oops. Okay. have to look at what I wrote for my lessons from ChatGPT. Okay. Let's see. Okay, so the way they wrote it. So let's try that. I'm not going to look at the whole solution, I'm just going to look at parts of it. Oops. Meaning that f of y is an element of by definition of the pre-image, it follows that is that how they wrote it? Usually when I see therefore, I usually think that they write the conclusion of the proof. But in this case, they basically wrote therefore y is equal to f of x, which is an element of every element of f is also in I gotta actually solidify this in my head because I was struggling with this. So basically, by definition of a pre-image, y, the y's. How did they wrote this? So the way they wrote it is that they wrote this as x, and it follows that y is equal to f of x, and it's an element of, so every element of f is also in y1, hence okay, so basically we get the pre-image, which is the first part here, and it follows that it's this, therefore y is equal to f of x, and which is an element of f1, so that every element of this is also in y1. So the pre-image is in this central part here, and once we get this part in the middle here, which is involved with this, then so basically we had to get this part to make this true. We had to actually break this down. So I was kind of right in my approach to just break that down first, and then it's just hard to actually like combine these two things. I think that was the thing that I was struggling with the most, because I thought I had to actually define this whole thing at the beginning, but I had to just define this part. And that was like the hard part, I think, because it's basically trying to make this small part bigger, involved with like the other function here. So I'll probably put a star here, just to basically, like, I don't keep the notes or anything, but like, you know I'm gonna upload this video on YouTube and I'll have it in my archives, so it's basically a problem I have to like look at. I'm pretty sure like a lot of people don't like looking at answers whenever they feel like they can't solve something. It's that feeling of defeat. You feel like you were not smart enough to get there, but then again, like, it could be just your ego talking. Okay. Actually, I think I have. And bring this down. This is the second one. So we have. So let's go down here. So let's I'm just trying to look back at the way we solved this. So that way I can solidify it, because I think the next one is going to be similar, but slightly different. So I think it's x1 is a subset. Yeah, it's a subset of f of x containing x1, so it's the reverse. Okay, proof. since we're dealing with x, maybe we have to write let x be an element of f of x, the inverse of because I think before this one is that how they wrote it? Oops. So they want us to actually define this, okay, so of pre-image, just bring this up for you guys. There we go. By definition of pre-image, hate this. No, I hate it when it's like I feel like I know how to get there, but at the same time it's just so, it's like it kind of slips out of my head. But then again, I think that's how it is with math. It's like, or at least math proofs, because it's like you kind of vaguely know what you want to say, but at the same time you don't know how to state it in a way that's like mathematically coherent. I'm probably going to repeat myself all the time when it comes to these like proof exercises, because it's like you know what it's supposed to, you know what you're trying to find. The problem is that writing it in a straightforward way that actually makes sense logically is really difficult, because it's like you have the intuition, like you have the feeling that you know where you're going. It's just that not being able to express it. That's the one thing that's tough. Because I keep looking at the example that we had before. Because the way they state it, I feel like it's somewhat similar though, but we have to do it in a different way because it has to do with x this time. So in this case we have y, so y is equal to f of x, and it's an element of y1, but now we have to show that this part is in x1. So if f of x is an element, if f of x1 is an element of f of x, mean, technically, didn't we already... No. Because we have to show that it's an x1. And... So maybe we have to do it by the definition of pre-image again. So by definition of pre-image. No, because pre-image is basically just it's I think is pre-image only for like when you're converting it to x, like from the inverse with a function, or can it work both ways? Because I feel like I have to say, like, by definition of it's like, you know, the inverse. Its inverse is x. It's an element of f of x, y. F of x, y. I feel like we're on the right track here. It's just since f of x1 is an element of f of xy, f of x1 is an element of f of x, which is its inverse is is an element of f of xy. Maybe we should put an equal sign. I think that would be better. Which is an element of x1. Thus, let's see. Let x be an element of the I feel like I didn't define something. Let's see, let x be an element of the inverse of the, by definition of the pre-image. And since it is an element of f of x, which is y. Oh, hey Zach, thank you for the raid. Much appreciated. If you guys in chat are not familiar with Zach, he's another awesome math streamer, way better than me. Oh, thank you for the follow, Ivan Neo. I will give you a shout out, Zach. How's it going? I'm just working on more proofs. Oh, thank you for thank you everyone that raided, and welcome raiders, welcome. FBI open up. I was like, what do you mean by that? And then I remember the meme and I'm like, oh, okay. Okay, yeah, so I am basically just doing some proofwriting right now, trying to give myself some practice, but the first one we did today, I was able to remember most of it, so we actually were able to solve this one, but this one we had to actually look at the solution, and I felt pretty defeated after that. Let me just erase this part for you guys. That's not very important. That was just like for my mental map here. So for this one, I basically tried to do it on my own and try to see if I can kind of use this as to help me to figure out how to write this one. But how was your stream, Zach? What'd you guys go over today? I'm pretty sure you guys probably went over some interesting math stuff. Let's see. Let x be an element of this. By definition of the pre-image, right? We got this and this. So since it is an element and it is equal to y, its inverse is for all of x is an element of f of x. There was quite a bit of complex variables. Try to find out Mathika and oh, okay. Mathika is a computer language, right? I don't know. What do you guys think of this proof? I mean, to me, it kind of feels like it's okay, but it probably is lacking somewhere. I'll let you guys be the judge. I mean, it's nice and short, which I like, but at the same time, it's like, I feel like it's lacking somewhere. I don't know what it is. Hey, Fizzbuzz. I also give you a shout out, Fizzbuzz. Didn't know you were also in the raid party. Fizzbuzz is another awesome streamer. They do talk about math, and they also do a little bit of programming. So if you're like into like mainly like programming and with math, check out Fizzbuzz's stuff too. I'm using Octave, but it uses Mathika syntax. Oh, okay, I see. Been lurking? Okay, I see. I don't know if this proof is good though. For all those who are more experienced in proofwriting than me, what do you guys think? Am I missing something in the proof? Does it look fine? I feel like it's lacking sophistication, or maybe lacking something in there. I mean, if it looks good, then I'll just move on. Because I think the next question is just figure out a counterexample to what is it? Find a counterexample for f of x1. Yeah, and I think the easiest one is like x squared in that case. Unless I'm wrong, which is likely, which is pretty likely. Actually, I'll be right back, guys. Just give me a second. I'm back. Let's see what you guys type. Math lab. Is it math lab? Honestly, all the languages blur together. That's funny. Probably right. I think I have a book on math lab, but I never actually took the course because when I went back to school, I actually tried to do engineering, but I ended up like dropping out, so I didn't actually had a chance to like take that course involving with the. I think like it's supposed to be like you program a certain system with like with math using engineering techniques, I think, but I never got to that course. I bought the book, but I didn't get to it because I ended up dropping out when I was like in the when I was trying to do an engineering associates. How would you state that that the function inverse is multi-valued? Like, what do you mean by that, Ivan Neo? That's actually a really good question to point out. At least we got like the pre-image part, and this one, I think this makes sense here because like there are multiple solutions for the inverse, right? There could be, yeah, there could be. I mean, Sascha, since you actually created the problem that I'm doing right here, how does it look? Is it lacking something? Like my solution to part 4 of the exercise 1 of the assignment. I mean, like I appreciate your support. Basically saying I'm cooking. I'm trying to cook. I don't see a problem with your proof, but I don't know if I'm just intuiting the answer instead of proving it. Oh, okay. I mean, like, what level of math are you taking, Ivan? You probably are higher than me, but like I don't know if you're doing computational math or you're doing both computational and proofwriting. Because I got a PhD in physics decades ago. Oh, okay. So you could probably teach me some physics. Because actually, like, there's a problem. There was a problem I saw in a textbook, and I don't want to look at the answer. And it's a pretty interesting problem. It's like I'll draw it. So it's like we have two walls. We have like a little, I think like a rod or something, and then we have like 3 springs. So we know the force on this and the force on this and the distance between these two. We'll call that x1, but it's defined already in the textbook. I don't remember the numbers by heart. And then we have this other spring, but we don't know the force here. And then we don't know the distance here from here. So we'll just call that just x. I think that's how the problem's set up. I haven't solved it yet, but I thought it was an interesting problem. I basically know nothing now. You should take xb inside of x1. Yeah, that's what I wrote in this part. Is the way I wrote it not clear? Like that's the thing that I'm struggling with, is because I feel like it makes sense in my head, but at the same time it's like, is that clear for the reader? At the very beginning. Oh, okay. So should I have wrote this at the beginning after this part, and for all x's in x1? Should I have wrote like this last part? Like, I mean, not this whole thing, but like this part, this section, like should this be like up here? To make it more convenient and more legible? You want to show that any element of is an element of a... So did I not do the proof right, or is it like I just have to move stuff around? Because the thing with proofwriting is like you prove the other way around. So does this mean this proof is not good? Maybe just erase this part. All of x is an element of x1. I mean, where did I go wrong though? Is it because I just wrote this part? Because it was the only way for me to think about to get x. Well, it would show that the other way around if f was an injective function, which I don't assume. Okay. So I should erase this whole thing? This whole lot, these like 2 lines here? Like, should I erase those 2 lines and just try to rewrite it rewrite it differently? Because I feel like the template for this proof is similar to this one. It's just that you have to actually alternate it so it fits x instead of like y in this case. Unless my mindset is not the correct assumption. The initial assumption is not good. Oh, okay. So I guess we're not really done with this thing then. So we're just gonna have to erase the whole thing. Okay. You want to take an x and this part now I'm starting to recall, because I remember ChatGPT typed out the same thing, I think. Funny enough, this was a valid for other inclusion when f is an injective. Oh yeah, because it's that, right? I forgot. Yeah, it's reverse. By definition of a pre-image. Since f of x is an element of f of x1, I know I have to. I don't want to look at the partial solution again because, like, I'm trying to actually like create this. The problem is that like, if I get so used to looking at the solution over and over again, but then again, I don't want to waste time. But of course, like, if you don't think about it, then you won't find the connection. But then again, if I think too much, then it's gonna waste time. That's the hard part. I guess I have to look at it. Okay, what did they wrote? Unless I didn't write it down. I probably didn't write it down. Yeah, I don't think I wrote this one down. So I actually have to like think about it now. By definition of the pre-image. I mean, at least we got through like 2 proofs. Although, like, I mean, I literally just got through 1, and the other one I actually had to look up. guess I'm gonna have to ask ChatGPT because I am completely lost. Written. Okay, so this is called the image. Okay, so the pre-image is obviously the inverse. Okay, so it's called the image. I gotta remember that whenever I define it. So now look at the definition of a pre-image. Okay, so what did I miss? So... So we basically have to go from the pre-image and then go back to the image. I mean, we did that with the last time we wrote it, but I think I just didn't write it the way it's supposed to. Or the way the way it was supposed to be layered. So I probably have to remember that if it's like in this type of formation, I probably have to write it like this, and if it's in this formation, I have to write it like this. Okay. Number 4, let's see. Find a counterexample to... I mean, I can think of one, but at the same time, it's like... Is that a proof question, or is that, like, actually just, something to think about? Because I think, like, let's see, if you have x squared, and you take the inverse of it... Like, I mean, that's how I think of it, like, with computational math, but doing a math proof with that, I think that's, like, something that I haven't done. I mean, at least we did number 2 right. I'm surprised I actually was able to kind of get this on recall. I didn't like memorize it, but at the same time it felt like it was like a muscle. Like I basically just kind of like felt like I knew where I was going writing it. But with these two, I felt like I got lost somewhere. But, you know, that's usually the struggle of actually getting better at solving problems. Okay, so how do we start this? Do we just pick like a function that we think will become like a counterexample to it, or do we just like try to like, I'm guessing we're supposed to make an assumption here, like probably f of x is going to be this function. Yeah, pretty much. Okay, so I guess we'll just say f of x is equivalent to f of x squared. Oops, no, I probably should write let then again, do we have to define x? Like x is I guess let x be an element of x1 and f of x is equal to There's a typo in the question. It's supposed to be x1 is equal to I think that's what you wrote down, isn't it? Yeah, x1 is equal to... Oh, it's supposed to be x1. Okay. I didn't see the little x there. There we go. feel like I know where this is going, but at the same time, I don't know if I'm writing the proof right. I mean, Sasha, am I on the right track here? Or am I just like going, or am I just like basically not writing things right? Take x1 equal to 1 and compute the right side of the equality. Right side of the equality. I.e., I mean, yeah, like it would lead a contradiction because it has to be both -1 and +1. Do I have to write anything more? Because like I just mostly wrote at the end like, but this leads to a contradiction. Unless I have to show it. Like I know where it was going towards, it's just that I'm not sure if I wrote it properly in the proof. That's why I was asking. Because I know with proof you actually have to show it like basically within the writing, and I'm not sure if I did that right. Like what else do I would have to add to the proof? Because I'm not putting the box yet until I know that the proof is done. I would probably pick x1 or something or something concrete and do the computation like you just did. Oh, okay. Squared is the same result as 1 squared, yet in the proof not included. Something like pick f of x is equal to 2, and then we have okay, so the way I write it is not proper then. That makes sense. Because according according to what Sascha is saying, because I remember that the chat is not on the screen, so if you're watching this on YouTube. Oh. Yeah, example, the counter example are usually just computations of some example. So I'm just writing it the way Sascha has written it for us. I've actually never seen this symbol before. That's interesting. Unless that's supposed to be not equal to. Like basically not equal to with a slash. Yeah, it's hard to do on keyboard. Yeah, gotcha. I mean, at least we did... I mean, technically, I only did number 2, like, on my own. But the other ones, I actually have to look over. I'm just marking them with a star, so I can probably look back at the video and just like look over what I miss here. Let's just make this nicer. Well, the struggle in math is always going to be real. You can't avoid that, unfortunately. I mean, we did more proofs this time. I mean, with a little help with ChatGPT as well. Okay. Exercise 2. You only got like 15 minutes left. That's fine. Let's see. We have an example here. So what is exercise 2? Okay, so good, it's 1 page. Let's shrink it a little bit. And let's copy this. Allow. Okay. So function show that. Okay, so number one, or part one of exercise 2. F has a left inverse. Show that F has, has a left inverse, applying that F is injective. Okay, so I think I'm going to have to ask, what is a left inverse? Let's see, a left inverse of a function f of f2 is a function g such that for all of x. Okay, this means that applying f and then g brings you back to the original input. Okay. I bet you this is how studying is going to be like in the future. Where it's, well, I mean, probably people are already applying this. So it's probably like a present day technique now. It's like, if I don't get it, I'll just go on ChatGPT. Hopefully they will provide a clear, concise way I can interpret it. Let's see, the key point, the identity function x is only worse if f is injective of y. For example, the left inverse is y. Do not confuse the right inverse h satisfies for all. Well, actually, that's also another good question. What is a right inverse of a function? Might as well be symmetric, just like learn both. Let's see, the right inverse of function x or y is a function. Okay, so it's somewhat similar. If you put this implies that h and then f get you back to the original function of y. Okay. The key condition: this is only possible if f is subjective. That is, every y in y must be reachable by f for some x in x, otherwise h of y would have nothing to put back from. Diagram view, you can think of the mapping as from x to f, y to x. Okay, do they have a diagram for the left one? Oops, just went too far. Where is it? Okay, what is the left inverse? So the right inverse basically gets you to y, while the left inverse basically gets you to x. Okay. Okay. So now we actually have to learn how to prove this. Proof. As a right inverse, then what's the third one? F has a left and right inverse, implying that F is bijective. Furthermore, the inverses are unique. Okay. Okay. Let's see. F has a left inverse, implying that F is injective. So we have to prove that F is a left inverse. So the way the definition looks like is that F has to map, and I think they put this, I think Sascha put it in the question. Yeah, like let F be a function from A to B. So for all, this implies the key point is the identity function on X. Now to prove that, because F is any function, so we can't assume that it's going to be a function that we know, or if we can't just make up one. We actually have to show that F definitely has a left inverse. Meaning, so it has to do with composites, the way it looks like. This means that F, applying F and then G brings you back to the original input. The question is, like, how do we prove that, though? Let's see, if F maps two different inputs to the same output G, wouldn't know which one to send back to. Do not confuse with right inverse. They even mentioned like linear algebra here. Irrevertibility in linear algebra. So I'm guessing linear algebra is like a big backbone to like the systems within math. Maybe I need to look at an example. But then again, this is an abstract function. I feel like if I type an example, it's probably going to show me like how to actually show it, and I might not learn anything. But then again, actually, what is exercise 3? show that? A and B are subjective. Oh, maybe we have to look at the example that Sascha presented to us. Here we go. Example. Let A and B be a function between two non-empty sets. We'll show if F is injective. Oh, here we go. That all of G be such that the identity of A, i.e. F has a left inverse. Proof. We call that this is consider is this S or G? I think this is S. Consider S as an inverse. Y is an element of the image of F. It is a collection of a non-empty set. Indeed, if F is an element of S, then thus all of X in A is Y. Thus, therefore, it's not the empty set by the axiom of choice. There exists H Thus the one choice is the image of F such that H on R is an element of R, and observe that the union is a subset of A. Thus the one choice function, as A is not empty, we can pick X, element of A, was following the... Oh, this is pretty long. Take A, then thus by injectivity of F have thus when. Okay, so I'm guessing you're supposed to do something similar with the technique of the right inverse. That's a lot. That's a lot. No, the other implication is much easier. What do you mean by that, Sascha? My example is the hardest direction. Oh, okay. Well, I guess we're gonna have to save this for next week, or maybe I'll work on it like outside of stream as well, just to get a better idea. F has a left inverse, implying that F is injective. But we also have to prove that. F is in the right inverse. If it's right inverses. So we have to find out proof techniques for these two, and hopefully we'll be able to find the proof. Hopefully those techniques will lead us to the proof for this. In my example, I showed the direction And in the exercise, I ask you to show the other direction. Oh, okay. I see. So basically in yours, you basically went backwards. Yeah, because F isn't... You basically suppose that F is injective, and you basically are showing... What's the conclusion here? Okay, I guess we'll save that for next time. I mean, we did make some progress this stream. I mean, granted, I only was able to do 1 out of the 4 that we did, but I guess that's progress, I guess. It was clearly better than yesterday. Yeah, but I felt like I cheated on the last 3. Because it's like I had to look at partial solutions and I didn't fully get it until I looked at the whole solution. This one was like pretty tough. Like these 2 were pretty tough for me because I was like, how do I write this? I mean, that's probably how you're supposed to feel when you take real analysis, because you're just banging your head on the obvious facts that you kind of know from like computational math, but then when you actually try to prove the ideas are actually legitimate, it gets really, really difficult. Maybe like that's my ego talking, I don't know. Because a part of me just feels kind of defeated, because I'm like, but then again, like probably like most people that are good at math, they'd be like, welcome to math, you're supposed to feel defeated all the time. And I think that's the same with physics too. It's like the more you do it, the dumber you feel, which is not a bad feeling, but at the same time, it's like you just have to get used to it. And for me, it's like sometimes like I still am not used to it, but then again, I guess like some people that do it in academia, they're never used to it. Well, proofwriting is sort of a language. It's hard to learn a language without hearing people speak it. Right, that's true. And sometimes I worry about looking at examples because, like, I'm afraid that there's only going to be one type of proof example, and then suddenly that's supposed to answer, like, the question that you probably provided for me, Sascha. Like, basically, it's like, I want to look at, like, how to prove something that's left injective. Left inverse. Has a left inverse, and I'm afraid that if I type that into ChatGPT, it's just going to give me the answer that probably you're expecting for that proof. But at the same time, like, I think with proofwriting, you don't know where to start, and I think a lot of people just struggle with how to start it. I mean, at least I was able to start some of these. This one I kind of felt bad about because I was like, dang, I remember this part. Like, as soon as you mentioned it, Sascha, I remembered it instantly, and I was like, oh my gosh, that's what ChatGPT said. Is ChatGPT good for math proofwriting? I never tried. I think for me, it made it a little bit much clearer. But then again, like, does it know, like, advanced proofwriting? I honestly don't know. But, like, thank you for the question, Mentan? Menten 017. That's a pretty interesting name. But yeah, I think we're gonna conclude the stream here, but thanks for joining me today, guys. You guys saw me struggle. You guys probably heard me grit my teeth over the mic, but you know, that's basically how it is to try to solve math proofs, or probably any subject that's probably like a little bit more brain heavy. For basic stuff, yes, but later undergrad class is it's a complete loss. Oh, okay, I see. So I guess it's good for real analysis, but if it's like something like topology or something, it's not really great, I'm guessing. But that's good to know. At least real analysis is kind of covered. Hopefully it has like some knowledge of linear algebra as well. At best, it will summarize the Wikipedia article. Oh, okay. I see. Okay. So, thank you for joining me today, guys. Yeah, no problem, no problem. I'm actually glad you asked, because like for me, like if I'm studying proofs on my own, which usually happens, like especially last night, I would rely on ChatGPT to basically give me some clue as to how to write stuff. And sometimes like I worry about depending on ChatGPT too much. But that's a good question to ask, Manta. Hopefully I'm pronouncing your name right. But thank you guys for joining me today. If you're watching this on YouTube, you know, drop a like, hit the notification bell, you know, also hit the subscribe button, and leave a comment down below if, you know, if you're liking the streams where I'm struggling with math proofs, like, you know, if you like this type of thing. In addition, like, you know, hopefully my struggle will kind of like allow you guys to feel like, hey, I'm not the only one that's suffering from like writing proofs or like struggling to like learn how to write proofs, you know. Math Stack Exchange probably has all the answers. Okay, yeah, I've heard of that one. Yeah, I've seen it on Google a couple times. But yeah, so also if you're on Twitch in the chat, I will put in the Discord server if you would like to join us on the Math Library Discord. And also if you're watching this on Twitch, you know, like if you like math and physics, please drop me a follow, much appreciated. If you want to see my math journey slash physics journey on this channel, you know, I always stream Monday, Tuesday and Wednesday at the same time, 2 to 4 o'clock p.m. Eastern time. So if you guys want to like basically catch up with me there, and also I will put my YouTube channel in the chat if you guys want to drop a sub there. And also, like, if you're watching this on YouTube, all the links will be in the description down below. Okay guys, I think that'll do it. I think that will do it for this week. Next week we'll continue on with the proofs. So the struggle will continue because I have to actually learn these proof techniques before Sascha goes into the next lecture that we're going to go into. I don't know how long that will take, but hopefully it won't take too long, because it seems like we're kind of going through an exercise like probably like every week. and he has a lot of exercises that I have to do, but at the same time this is just me basically trying to do proofwriting and try to get used to actually like trying to think about how proofs are written. So hopefully you guys are also learning from my experience. And also I make mistakes in my writing of proofs, and I also make my mistakes in whenever I do calculational math or physics problems. I leave them in there because, like, you know, I can make mistakes, and if you guys are paying attention and you do the problem for yourselves, you can basically put it in the comments down below. If you're watching this on YouTube, it's like, hey, you made a mistake on this one, or, you know, if I don't catch it during the stream. So yeah, so thank you guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys next week. So take care, guys. Bye-bye.